When you say prosthesis, they think of leg or an arm, but they don't really think about skull. My name is Jessie San. I am the case manager at OsteoSymbionics. We create craniofacial implants for patients who have been through trauma, through a motorcycle accident or a car accident, or they have gone through craniotomy to remove a brain tumor or an aneurysm, or they were born with a certain defect. They lose a piece of their skull. What we have to do then is go in and design a prosthesis or an implant that fits that part of the skull that they lost. The process of creating a craniofacial implant starts with the patient's CT scan. So this is the CT software that we use to review the CT scan from each patient. And using this software, we can create a 3D skull model of the patient. So what you see here on the screen is a 3D model of the patient's skull. This is what we use to create the template and the final implant for each patient. We'll create a skull model from the patient's own CT, and then I can design the implant for that patient using our digital software. After we create a 3D skull model, I can import the file into the software, and using this I can design the implant for this patient. So this is where science and design meet. It's the software. And then afterward, we'll fabricate and manufacture the final implant using a molding and casting process. So this is what we designed on the digital software. We'll create a negative using this template. And this is a plaster mold. So we do a molding process, and then what we get is a negative impression of the template. And then we'll go ahead and fill this mold with the PMMA material and put it in the oven and heat cure the PMMA so that we get a positive final implant. And then afterward, we have technicians in the back, and they'll fit and finish a final implant so that every single one fits the skull model before they leave our facility to ensure that the surgeon has a near perfect fit. There's an art aspect into designing these implants, and there's also a science aspect because everything has to fit perfectly. And you have to know the anatomy, the physiology, the biology that's behind each defect, because you have to tailor each implant to what the surgeon and what the patient needs. So it's a great way of combining both art and science.